Oh. How we doing, everybody? Welcome to the stream. It's your boy Joey. How we doing? I love my little characters. Dance, you people, dance. I'm so got a big head. Even worse, you can see. Hello, I can see you. Oh, where did I go? Oh, I'm all messed up. Fix it, fix it. Oh, this didn't fix it. Nope. Hello. It is me. It is you. Alright, enough of that. I have too much fun with that every time. I don't know why. I love it. Alright. How we doing, everybody? Welcome to another stream. It's your boy, it's Joey. Hope everyone's doing good out there. Just to give everybody fair warning, my stream might be broken today. Not because of me. Twitch is a little bit of broken today. So if I lose audio, if I lose video at some point, if it freezes, if it does something goofy, man, this red does not like. There's the blue. There it goes. The red just didn't want to focus for some reason. So again, if I lose audio, or if it freezes or something like that, guys, I'm gonna apologize ahead of time. Twitch has been broken for better half of the day. So again, if it gets all goofy on me, yeah, I'm sorry. So all right. So like we pretty much we're gonna pick up where we left off on Friday. Remember, we got into part 6 finally. So that's the beginning of OSPF. We're gonna be on Cisco Packet Tracer today. I got my Windows VM booted up, ready to go. I just downloaded Discord to it too, because of I'm gonna give you guys a kind of like a preview of what my Discord channel is starting to look like too today. So that should be exciting. And the reason why I downloaded Discord to that Windows VM is for the purposes of updating the Packet Tracer Labs onto it as we go. So it'll just be, I'll be working on the labs on that VM, and then I'll be just loading those labs up right to my Discord server from there. So that'll be, what I was gonna do today. Today, I thought it'd be a great idea if my stinking butt was to, if I was to actually monitor the YouTube chat today. That's been something I've been kicking my butt about. So again, if you guys any of you YouTubers out there, I apologize. It's been a long time since I've been streaming on there, but I haven't been monitoring the chat to see if anything pops up in there. So today I got Twitch over here. I got the YouTube over here. Facebook. I never get any comments on Facebook, so that's fine. But if you're on Facebook, come join me on Twitch. If you're on YouTube, come join me on Twitch. I want to give a big shout out to was it Mini Moose? I think it was Mini Moose. King Mini Moose, and Ginger Peb. Good looking out on the follows. you guys have got me one step closer to my affiliate goal. I'm finally at 50, but I need an average of 3 viewers per stream. No. To get affiliate. So we're almost there, guys. We're almost there. We got to 50, so that was a huge accomplishment. And thank you everybody out there who's been following my channel. So mwah! Thank you so much, guys. You guys are awesome. Every single one of you guys are awesome. But yeah, like I said, we're gonna jump into to part 6 today, OSPF. We're gonna crush some of that out. I've been trying to listen to some David Bumble videos and stuff like that about OSPF, just to kind of give my brain a ramming head start into all things OSPF. Man, everything is gonna fall and break today, isn't it? Oh, my lights are falling. Oh. Man, I don't know what it is, guys. I don't know what is going on at work, but I've been thinking breaking out in hives, and I don't break out in freaking hives. It's getting annoying. I keep scratching them. All right, so let's get ready to rumble, guys. Let's curious on how I want to start, because you know what I didn't boot up was my Epic Pen. Get Epic Pen up in here. Here's me Epic Pen. Alright, so I kind of want to do a review on because of what happened. Because of what happened last week. Well, not what happened last week. More of the fact of more around the fact of what I was struggling with on when we did the review last week. It seemed like I was struggling hardcore with submitting questions for some reason, and that's not cool. So because of that, I think we need to take a subnetting quiz to start things off with. Let's take a subnetting quiz, and let's go from here. All right, let me switch my cameras. Appropriate there. All right, so that's cool for now. All right, so let's. Should I move to the whiteboard? I don't know. All right, let's just dive into this one first, and then we'll see if we should move to the whiteboard. Okay. What is the network ID of the class A, B, or C network containing? What is the network ID for the class A, B, or C network containing? All right. What is the network ID? The A, B, or C network. This is a class A network. What is the network ID for the class A, B, or C network containing the 141? So this is a class B, right? Yeah, it's a class B network, class B. So it'd be this one. What is the network ID? All right, so let me just write this down for you guys. So class A is from class A is from 0.0.0.0 to 127.5.5. Brain fire today. All right, class B is from 128. 0.0 to 191. That's 5. C 8 120 192. Yeah, I even wrote 192. I'm losing my noodle baker. And that's to 224, right? 223. 5 5 5. That's the class D is 224.0.0.0 to 239. 239. Class D. Class E is 240.0.0.0. That ends at 5. All right. And then, all right, so RFC 1918 10.0 to 10.5. All right, localhost 7.0.0.0 C 18 172 16.0.0 2 3 1 5 5 C 1918 2 6 8 0 2 6 8. All right, so here's our little breakdown for how our network. Well, here's our classes. So this is our classes. So we have class A, B, C, D. All right, this is classful IP networks. Okay, RFC 1918. These are private. All right, private networks. So you have the RFC 1918 that pretty much governs the private IP network classes right here. Okay, so all right, so 50.221. So what do we got? We got that in the class A. So here we go. All right, the network ID for the class A, B, or C network 172. So if we look over here, 172 is a class B. So it'd be right there. The network ID for a class A, B, C network containing the 10s. All right. The classful ID for the 60. So again, that'd be a class A still. 1110, so class A still. All right. 140, that's a class B now. Okay, so it'd be 140.12. Okay. What is the network ID for the 190.190? So 190.190, that would be a class B. All right. What is the classful ID for 104? So 104 is a class A. All right. That went pretty well, but that was a fairly easy test. All right. So that was a little easy, so that's fine. Let's do this. Let's do most difficult. All right. For our class ABC network containing 222, 255, 255.1, with the subnet mask of 225, 225, 225. What is the network ID and the broadcast address here? Do this. Where are we at? So, what do we got? We got our subnet mask. So let's do our subnet mask first. So we have 225.25.25.0, and our IP address 2.2.2, 255.255.1. All right. So, what is the network ID? So remember, we have zeros there. This turns into a 0, so it'll be 2.2.2.5, 2.5. Because remember, these all stay the same because these are full of binary ones. Remember, so 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And this is full of binary zeros. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So this automatically turns into a 0. Okay. So the 222.255.255.0, this would be the subnet ID. All right. And then to get the broadcast address, all we do is fill this with binary 1. So 1, 2, 3, 4, 5, 6, 7, 8, turning that into a 255. All right, so it'll be 255, 255, 222. All right, so 255, 255, 255 is the subnet broadcast. Okay. So what we got? 222, 255, 255.0, and then we have 222.255.255.255, right? All right. Let's up real quickie. Do the next one, guys. All right, now we have, all right, so what do we got? What is the, all right, so we have a subnet mask of 255.0.0.0, right? And we have a IP address of 50.0.0.1. So remember, we have all zeros here. So again, this turns into a 0. So the network ID would be 50.0.0.0. And we have all binary zeros here. So to find the broadcast address, we fill these full of binary ones. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. giving us a broadcast address of 50.245.245.245. All right. All right. All right. So the broadcast ID is 50.0.0.0. Broadcast is 50.255. Just clean that all up. Not too much on there. How are we doing, everybody? Oh, let me get over here real quick. All right, so we're back here. All right, so we have an IP address of 245.0.0.0. IP address is 100.88.204. Clean that up. 255.0.0.0 and 100. Epic fail today. .88.204. We're just going over some so because I did a review last week and it seemed like my subnetting, I was struggling on my subnetting portion of that test. I just wanted to review. We're going to get into OSPF, but I wanted to just review subnetting real quick again, just because I don't need to fall off of my subnetting practice. There we go. Okay. So we need this network ID here. So remember, this is for all binary zeros. So these all turn into binaries. These all turn into zeros. So it'll be 100, 0.0.0, and then 100. 2 for 5, 2 for 5, 2 for 5. All right. Easy peasy lemon squeezy. So 100, 0.0.0. All right, do 100, 2.5, 2.5, 2.5. All right. Let's keep it going here. All right. 2 for 5, 2 for 5, .0.0, 191, 44, 55, 11. Binary zeros here, so these turn into binary zeros. 191, 44, .0.0, 191, 44, .255, .255. All right, easy peasy. 1, 44, .0.0, 191, 44, 55. 255, 255, 00, 191, 0.0.1, 191. It's a Wanjo .0.255, .255. 191. 0.0.0, 191.0.255.255. All right, next one. There's only a couple more. Right. We got 255, 255, 255.0, 223. 255, 255, 1. Again, this turns into a binary because this right here is a 0. So this turns into a 0 for the subnet ID. So 223, 255, 255.0. And then to get the subnet broadcast address, we just fill this full of binary ones. 1, 2, 3, 4, 5, 6, 7, 8. Give it us 223, 255, 255, 255. All right. 223, 255, 255.0, 223, 255, 5.25. Okay. All right, next one. What do we got? 255, 255, 255, 0, 200.5.18.97. All remember, so this one's full of binary zeros, so this turns into a binary 0 here. So 200.5.18.0. Now again, to get the subnet broadcast address, fill this just binary ones. Okay, so it'd be 200.5.18.255. 200.5.18.0. 200.5.18. These ones are pretty easy. I thought these ones would be a little bit harder. They're actually pretty easy. So. Eat a fine, man. Eat a good. All right, what do we got? So 255, 255, 00, 128, 0, 77, 199. These two binary zeros, so these two octets right there turn into binary zeros, so it'll be 128, 0.0.0. And then to get the subnet broadcast address, we just take these two octets, we fill binary zeros, so we 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, giving us a subnet broadcast of 128.0.255.255. One 28.0.0, 128.0.255.255. All right, next one. 255, 255, 255, 0, 192, 1, 1, 244. All right, again, zeros in the last octet, so this octet turns into a 0, so 192.1.1.0. Now this octet, to get the subnet broadcast address, fill it full of binary ones, so we 192.1.1.255. All right, 192.1.1.0. 1.1.1.255. Next, please. All right, there we go. Last one. Again, very easy. 255, 255, 0, 192.0.0.1. Last octet. Remember, this turns into a 0 here. So it'll be 192.0.0.0. Again, this octet here, okay, fill it full of binary zeros, 1, 2, 3, 4, 5, 6, 7, 8. Turns this to a 255. So it'll be 192.0.0.255 to get the subnet broadcast address. Okay. So 192.0.0.0, 192.0.0.255. All right, that concludes that. Again, I thought that would have been a little bit harder for us, but I guess it wasn't. So, all right, but I don't want to waste too much time on that. I just needed to review some subnetting real quick, just because of how we got beat up last time on the actual, when we took the big exam last week. Well, at least the practice exam, chapter 13, 14. Chapter 13 and 14 really beat me up. So that's it. That's all. I just wanted to just hit chapter 13 and 14 and some subnetting real quick because of what it, again, I need to make sure, well, that's what this is all about. It's about continuing study for this. So we only got 4 questions to do. So stick around for these 4 questions. So an engineer first confirms that the router's interface 500 is up and working. He confirms that the interface with the IP address 10.101.101.101, 255.255.128. The engineer leaves configuration mode, issues the show IP command. Which of the following masks will be listed at the output description, the connected route as the existing the IP address command. So we're just looking for the we're looking for the slash notation for 120, 255, 255, 128. So that would be what is that, 20, 25? Yeah, 25. Figure shows an IP. The figure shows IP addressing for all network devices in a small lab network. PC1 can ping PC3. Which of the following statements accurately describes the allowed space of the IP for IP addressing growth in this design? All right. So what do we have here? So with 2 IP addresses assigned to router 3, local subnet allows for 12 additional IP addresses. All right, so let's take a look at what we got. Let's just do some subnetting math real quick. So we have 28. So 28 gives us a subnet mask of 240. So we have 255, 255, 255, 240. All right. So to get the so what we do is do 256 minus 240. All right. So 256 minus 240 gives us 16. Okay. So we got a IP address of 172 225.25.25. All right. So we do 0, 16. All right. 32. All right. So the addresses between obviously 16 and 32. So we minus 1 from there. So our first, so here we go. So we'll just break this out. So 25, get my eraser. It's awful. All right, so it'd be 25, 25.16. All right, this is the subnet ID, okay? The subnet broadcast address is 172.25.25.31, okay? So how many addresses do we have between these two numbers right here? All right, so let's go down here. My handy calculator. So 16 minus 31 gives us 15 addresses. Okay. All right, so a total of 15. What do we got? So with 2 IP addresses assigned, R3 subnet allows for 12 additional IP addresses. So with 2 addresses assigned, let's see. Yeah, that would be right. Because you got to take out the subnet ID here. And then he has 2. So that's 14 minus 2. So that's 12. All right, R1 subnet supports R1 subnet supports more than 600 or 300 hosts. The subnet that is used on the serial link allows for an additional 4, but they are wasted. Just take a look. So what do we got? All right, so it's either gonna be one of these next, not one of these next ones. So let's do the serial link question real quick. All right, so /30. The subnet that's used on the serial link allows for four additional IP addresses, but they are wasted because there is no other IP. No, it only allows for actual 4 IP addresses on a /30 mask. Yeah, it only allows for 4. So there's not 6. So this one, so we can always tell that this one right here is wrong anyways. So let's move over to here. So what do we got? We got 23. So 23 gives us a mask of 245, 245, 254, 255.254.0. So 256 minus 254. All right, obviously it's 2. So this goes up in increments of 2. So you have 0, 2 all the way to 200. All right. All right. So obviously 200 can go into 2. All right. The next IP address would be 202 minus 1 would be 201. All right. So let's do. So what we got? We got 201. Oh yeah, that's what's going on. Not 200, it's 4. Yeah, so uh, yeah, so it's 2, 0, obviously 2, and then 4. So right here, not 6, 5. So be 1 10.4.4.0. So that ID, and then 10.4.5.255. Okay, so this is our available IP address range. So how many hosts can it fit? All right. So I believe it's going to be more than 300. So what do we got? So we got 0. So we got 254. Yeah. Yeah. Let's go with 300. More than 300. We're good. We got that one right. I had a feeling we were right on that one. All right. Which of the following IP addresses could be assigned to a host? All right. Assigned to a host. So let's see here. I know it can't be that one. And then these two. This one. Go with these two. Yep. All right. The diagram shows a small network with three VLANs. The network engineer needs to assign IP addresses to the host to allow them to communicate with each other. Which two of the following answers accurately describe the requirement for addressing the small network? All right, what do we got? So the PC11 IP address must be in the same subnet as 21. Nope. PC31's IP address must be in a different subnet than PC32. Yep. So that one's right. If PC2's address is 10.99.88.77 with mask 25, Yep, that's wrong. So it's this one. All right. So this is, so look at that. So with the mask 2525252, then assign PC31's IP address with 10 998978 with mask 2552525 would not cause problems. It would cause problems because they're in different subnet masks. Cool. All right. All right, cool. So we did a quick review on those 2 chapters, and I feel happy, peppy. I'm so happy. All right, now let's get over to OSPF. All right. Let's get on to OSPF, man. Teaching shipping my shelter waters. Oh, buddy. All right. OSPF time. I have some, yeah. All right. So let's do it to it. All right. So this is where we ended yesterday. So let's just do, I guess, just a quick look at. So where we kind of left off was talking about what OSPF was doing. So we made a network. We made a network in Cisco Modeling Lab where we left off. Where we left off on Friday. And what we took a look at is how OSPF dynamically adds routes and like it, how it just works within the network. Okay, we're gonna go through what it's actually doing now as we continue on. So let's just start off here. Interior and exterior gateway routers. IP routing protocols fall into 2 major categories. Interior gateways, IGPs, and exterior gateways, EGPs. The definitions of each are as the following. IGPs, a routing protocol that was designed intended for use inside a single autonomous system. Okay, there's that word, special word we have to continue to remember. Autonomous system, AS. Okay, so when we see ASN, autonomous system number. Okay, ASN, autonomous system number. That's going to continue to come up very shortly. All right, EGP, a routing protocol that was designed and intended. Holy thingy-maboobers. I'm getting a million notifications here. All right. What was I gonna say? You know what I didn't see was a notification in my thingy-boober. Oh, no, come on, come back to me, man, come back. How's my host doing? Here's gonna be a quick preview of my my Discord, guys. Just an FYI's. All right. So did my stream announcements go through for myself? They did. 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 Oh, what time? All right. So they started right about when I started. Oh, look at that. It's like a Twitch and YouTube. Man, something I guess is going really on with Twitch. Look at that. So this started exactly when I started, and this took about 10 minutes after the fact. That's crazy. So here's a quick look at my Discord, guys. And this is what's going to be coming out. This is what I've been working on. All right. There's some things I got to change in here. But I mean, it is pretty good so far. But I got feeds and everything else coming through my Discord now, for you guys. What I'm trying to set up is I'm trying to set it up in a way, that you guys, this can be like a portal for you guys to get all the information that you guys want. And that's what I've been really aiming for this, um, for this Discord itself. Okay, because I got Reddit feeds coming in here. All right, I got Reddit feeds that all about some of the, at least some of the topics that I'm very interested in: CCNA, VMware, system admin, some home labbing, Linux, networking. I added Nutanix. I don't know much about Nutanix, but I guess there's issues going on between VMware and Nutanix right now. And that's the only reason why I added this, just because I want to be aware of what's going on between those two companies because of what I do in VMware. Um, I need to be on top of what's going on between these two companies right now. And that's why I added this. So if there's anybody out there that has hatred between either one of these, I'm sorry, but I need to know what's going on between those two. So these are Reddit. Again, these are Reddit feeds that are coming in. I got my little Joey bot over here. He's pulling all these, he's pulling all this information from Reddit. I got him also pulling things off of Twitter as well from some of the guys that I follow. Jeremy over here. We got David Bumble, Hake Preston, Kevin Wallace. All right. This is IT Pro TV. All right. So don't mind some of these pictures here. All right. My boy Keith Baker over here. I love that guy. Again, we got David Bumble. I love me some David Bumble. He's an amazing person. So I got, these are just some Twitter feeds that, again, I got my Joe bot filling in information for us. Again, I also got what's his name, being Chuck Black. Chuck Black. He's great too. This is the group that I followed, my gooses. This is a Bruce Green type thing. So this is if you're into Bruce Green or anything like that, you'll know what the gooses are. All right. But I also, in my little CCNAers group here, I got David Bumble videos. Again, my Discord is gonna be a place for where you guys can get updates and stuff like that for all things awesome, that are evolved around networking and stuff like that. So I got Keith Baker's, when Keith Baker makes a video, when David Bumble drops a video. I also have Hake Preston on there too as well, because he's got a YouTube channel as well. And give these people some love. Again, if you are a goose, or if you know the gooses, go over to my goose channel here. Go follow my gooses. Show them some love as well too, guys. But this is what I've been working on. It's not complete yet. All right. My oh, what up, man? What up, my man? Doc Spat, what's up? How we doing? I'm kind of just I'm just showing everybody, my Discord server that I've been working on for a little bit. I haven't put it out there yet. Right, buddy? WBY. Yeah, man. So we're gonna be going over OSPF and stuff like that today. The reason, yeah, you know what? What I will do, let me make an invite, and I could I'll drop you the invite, so you'd be one of the first people to join up in here. No, not that one. I know why it's not doing this. It's because, all right. Q D P. Right? That good? Yeah, that's good. There you go. You'll be one of the first ones to join up in it. Like I said, it's not done yet. I've been working on it. Um, so what it will be is I'm going to be setting it up where um, you could choose to get notifications when certain things come up. Um, like over here, like if you want to have like these feeds, if you want to get notifications when these guys feed, you know what I'm saying? I'll have roles and stuff like that where you can be part of the networking tweeters, or when these guys drop, you know, their YouTube videos, you can be part of the network YouTubers. Same thing with these Reddit posts here. Got to drop out of that VM. Just give me the same one too, right? No, all right. I see where. All right. There you go. What up? Thank you for joining, my main man. My main man, Marada. Docspat. So yeah, man. Hey, you know what? Do me a favor. Um, you know what? I gotta add you. I gotta give you a role. Let me just come over here real quick. Let me give you a role real quick. Because if not, you probably can't see everything right now. Oh, you came in as a member. All right, so you could see everything, right? Do me a favor while you're there. Um, Check it out. Tell me what you think. Tell me how it looks. You know what I'm saying? Docspat. Um, that way, um, give me some, if you have any suggestions and stuff like that on what else to do to it. I've been really trying to I want to make it like a place where, you know, um, I want to make it a place that you can get. Yeah, so that's what I'm kind of thinking too, and that's what I want to build into this, as well. Um, I've been really like YouTubing like how to like get my to get everything like really nice in this little Discord channel too. Um, so yeah, give me drop suggestions in the Discord and stuff like that. I'll make like a suggestion. I'll make a little suggestion channel too in there. That way you guys can you can give me everything that you think should be in there and stuff like that, and I'll work at building it in there. Um, you know what I'm saying? And yeah, man, thank you so much for joining in, brother. I appreciate that. I hope it's again. I hope it's pretty neat. Um, and there'll be more. I'll be working on more of it. And this one right here, this packet tracer. This is where I'm gonna be dumping all of the packet tracer labs into. Actually, you know what I can do is while I'm here. So I can add these packet tracer labs. I can add those packet tracer labs in there, and then you can. I don't know if you've got packet tracer downloaded, but that was the point behind this was to. I thought I had more labs in here. I guess my other labs didn't really save too much. That's fine. All right. I'm running Discord on everything over here. All right, so let's actually start off by building a small topology. Take one of the empty ones. You know what I was thinking is to do something like this today. That way we can take out some routes and whatnot, and that way we can take a look at how if we remove some routes, what will happen, and we'll go over DVRs and how that works out and stuff like that too as well. All right, that's fine. Gigabeats. Get to turn it off. If Twitch breaks today, I was telling everybody this in the beginning. If Twitch breaks today, Mad Docs, I apologize for that. Twitch has been breaking like crazy lately. So I just give everybody a fair warning about it. All right, there we go. All right, so we got that. we get that set up. Those routers are gonna just do their thing real quick. Come over here. We'll add some cabling. Beautiful, beautiful, beautiful. Oh, you know what? You know what we should do? We should do like this too. Do this. Just turn you off real quick. One more. You. Very good. And then we'll take a look at what goes on this kind of network here, where we'll have some multiple different pathways and stuff like that. We'll see how OSPF makes its choices and stuff like that. And that's what I want to take a look at with OSPF today. Let's change this to 1. Two. Will you configure loopbacks, all gigabit interfaces? If so, maybe include a fast Ethernet 2 or a serial link. All right. Yeah, so I was gonna configure loopbacks on all of them, but we could add some serial links too. Let's do this then. Let's do this then. Serial. It's the serial link here. Fiber. Got one of those. Back to this one. Serial. All right. We'll add a serial link. This one. Let's go. What is this? Is this a fast Ethernet? It's a fast Ethernet. Boom. Oh, did I turn that on? I might have not turned that on. Yep, I did. All right, fast Ethernet. Boop. All right. Let's add linky links. Fast Ethernet. The fast Ethernet. All right. So we got some. Thank you on that suggestion too, Mad Dogs. I appreciate that, man. All right. So we got some linky links over here. All right. We have a serial. We have a fast Ethernet. Then we have some gigabits. We're going to dive into some OSPFing. Call you router 3. And call you router 4. what we'll do for addressing, is we'll say, we'll keep the addressing quite simple. That way we don't get too crazy with everything. So we'll just say 10.0.0.1.1, all right, /24, all right. Then we'll say 10.0.2.1/24, 10.0.3.1/24, 10.0.4/1/24, and then 10.0.5/1/24, and then 10.0.6.1/24. All right. We're going to keep the IP subnetting simple on all the links here. Again, I don't want to get too crazy into spending too much time on that. Mainly, I just want to get into OSPF here. All right. So, enable property. All right. So, let me just populate my interfaces real quick, so that way I don't have to take too much time trying to figure out what it is widths again. There we go. Cool. All right. So let's get into interface gigabit. What's that? 0/0. All right. IP address 10.0.1.1. 2.5.2.5.0. IP address 10.0.1.1. Oh, I put an extra period there. Going too fast again. All right. No shit. All right. Interface. What is that? Gigabit 0-1. Gigabit 1-0. All right. So that's going to be, we'll give that the IP address 10.0.4.1. 2.5.2.5.2.5.0. No shut. All right. Interface loopback 1. IP address 1.1.1.1 2.5.5.2.5 5. All right. And then interface 2/0. That's on the fast Ethernet. All right. And we're going to give that the IP address of 10.0.5.1.5.0. Shot. Did I give the other interface? Yeah, I gave that the no shut. All right, so we're good. All right. Exit. Now we're gonna do router. Router OSPF. Version 1. Network 10.0.0.0. Say 0.0.0.0. I'll just say 25 right there. Area. I'm going to keep it tight. So we'll say 255.255. Area 0. All right. That's it. And we'll say do red. All right. So router 1 should be configured. Go over here to router 2. Let's go to the command line. Say no. All right. We'll see how fast we can do this. All right. So what do we got? Interface gigabit 0-0 IP address, and that's in the 1. So we're gonna say 10.0.1.2 255.255.255.0. No shut. All right, now it's interface, gigabit, 1-0, IP address, 10.0.2.1, 255.255.0, no shut. All right, that's good. Now we're gonna go interface, serial, 3-0. 3-0. We're gonna give that the IP address of IP address 10.0.6.1 255.0 shut interface loopback 1. All right, we're gonna give this the IP address of 2.2.2.2 255. 255. Okay. Exit. Router. OSPF. Version 1. All right. Now we're going to say network. 10.0.0.0. 0.0.255. Area. 0. All right. Right. All right. We just made our adjacency. Okay. We made our adjacency with router 1 over here. Okay. All right. So we can exit out of there now. Now let's come over here to router 3. All right. EN. For D. All right. Interface. Gigabit 0-0. All right, IP address. Now this is going to be 10.0.4.2, 255.255.0. We're going to give that the no shutty shut. Okay. Now interface, gigabit 1-0. The address. What do we got? Threes now. Okay. 10.0.3.1, 255.255.255.0. No shut interface, and that's the serial link now. Serial 3-0 IP address 10.0.6.2 255.255.0. No shut. All right. So we got that one. We're looking pretty good. All right. Interface. Loopback. Interface, loopback. Okay. IP address 3.3.3.3, 255. All right. Now let's implement OSPF on this one. OSPF version 1. We're gonna say network. If anybody has any questions at any time, just throw it in chat. I am watching YouTube chat today, so if you guys are watching me on YouTube, I am watching YouTube chat today. So if you guys are on YouTube, chat it up on YouTube. If you guys are on Twitch, watch me on Twitch. I'm watching both chat. So again, at any time, any questions, just stop me, and I will answer the question. 10.0.0.0, 0.0.255. Area 0. All right. Exit. Do right. All right. So we just made our adjacency with router 2, and there's our adjacency with router 1. All right. All right. So everything's going pretty good. All right. Over here. Over here. To router 4. All right. What's our interfaces? So interface gigabit 0-0, and that is in the 3s area, right? Yep. Okay. IP address 10.0.3. If you change the router ID after the OSPF has finished analyzing, we'll change the hierarchy. That's That's exactly. Thank you for that, Mad Ducks, because that's what I wanted to see today. Because I was watching, I was going over, David's Udemy videos today, and he had made a lab where he had a similar setup where he had a whole bunch of routers, and they had I'm getting Discord things on this VM. He had a lab where he made, and he had OSPF already working in the lab, and it was going kind of against what OSPF should be doing. Well, at least what OSPF, how it creates its DBRs and all that stuff, because of, I guess, like, it goes off of like whatever router like comes up first in OSPF, then that becomes the DBR no matter what, or something like that. So that's what I wanted to lab up today, because exactly what you said was, by changing some things, it kind of like regroups the hierarchy, and the way that OSPF is acting within the topology. So these are the couple of things that I wanted to take a look at with OSPF. So that's why I'm kind of curious to see how it all pans out once we get this all together, and we'll start. We'll break it a couple different ways, and then we'll take a look at what went wrong and what's going on and stuff like that. So, I think OSPF is pretty stinking neat. All right, so what's our last? So we got a couple more interfaces on this one. So that one's up. So interface. What's that? Gigabit 1.0. Okay. IP address. What's that one? 10.0.2.2.255.255.0. No shut on that one. And then we have an interface 5.0.2.0 IP address 10.0.5.2 255.255.0. No shut on that one. All right, interface loopback 1 IP address 4.4.4.4 55.55.55. That's it. All right, now let's do router OSPF version 1 network 10.0.0.0 0.0.255 is 0. All right. Exit. Do right. And we should be making our adjacencies. Very good. Very good. Awesome. So you guys can just see. So if you guys, let me move this over so my big head doesn't get in the way, and then I can cross those over. All right. So you can see we just made our adjacencies with all the other routers here. All right. So if we take a look at our, let's do a do show IP route. All right. So you can see all of our routes. So again, what I can do, because I don't want that getting in the way of it. It's fine. Yeah, whatever. We'll erase it off. Okay. I can always go back and fix that. So right here. So when we see these O's right here, this is routes that OSPF, this router has learned via OSPF. Okay. So you can see right here the 10.0.6 network, the 10.0.4 network, and the 10.0.1 network, okay? All All right. And we can, I'm pretty sure. So let me just get some OSPF show commands too, so we can take a look at that. OSPF. Let me get to where my OSPF stuff is. There we go. Okay. All right. So let's do this. Do show POSPF. That's not good. So let's do a do show IP OSPF neighbor. Spill it all over, aren't you? Want you? All right, what do we got? So what do we got? What do we got? So 0.2 neighbor is 2.2.2, which is router 2 over here. Interface, detail. So off of this interface, in area, neighbor is 1, state is full, DR, DVR. So we're the DVR, and R2 is the DR for the 10.0.2.1 network. Then we also have another neighbor 1.1.1, which is off of this fast Ethernet link over here. Oh, dude, I'm gonna get mad. Oh no, come on. See, there it comes back. All right, guys, I'm sorry about that. Twitch has been breaking all day long. I just lost everybody on YouTube. Did I lose everybody on YouTube too? All right. Thank you guys for hanging out still. Again, Twitch has been breaking all day long, so I apologize for that, guys. Yeah, let me do this too. Yeah, I'm gonna save this lab, guys. Save this lab. See, look how many labs are in here, but they didn't show up on my other one for some reason. That's weird. Where the heck are these labs being saved to? That's right. Oh, that's funny. All right. All right. YouTubers, thank you for coming back. Twitchers, I'm sorry. It just keeps breaking on me. So I apologize for that. Let me save this lab real quick. We're gonna call it OSPF. OSPF. I'm gonna put this lab up in here too, guys. You guys can take a look at it too. I just added all of my other. I don't know where these. I don't remember where these ones came from, but I just added all of these up in here. Again, if anybody I'll be having my link to my I'll have my link to my Discord account. Well, not my Discord account, but my Discord server here pretty soon, guys. So, um, yeah. What I'll do is on YouTube. If anybody's interested on YouTube, I'll drop it in there as well. Yeah, yeah. All right. I posted that up in the YouTube chat if anybody's interested in joining the Discord as well as on Twitch, guys. I did post it. I'll grab it again. I'll post it again up in the chat. All right. Thank you very much, Mad. I appreciate that, Mad Dogbacks. Docsbat. I appreciate that, man. Yeah, I'll take a look. I'll take a look at that. I'll take a look at that my link to make sure that it's still good. If anybody has any issues with that link, just give me a shout, all right, guys. But I just posted. If you go to the Packet Tracer channel, I just posted all of my labs in there, and the OSPF -1 lab is the one that I'm working on right now. So if you're interested, that's it right there, and it should just be it's updated to where I'm at so far. So if you wanna jump on that and join me as we're going along, you're more than welcome. Okay. All right. So let's take a look here. Let's do a do show IP OSPF summary. That's not database. Database summary. All right, so there is our ID. All right, process ID 1. So what the loopback address is doing for us is the loopback address is giving that as our OSPF router ID. All right. So that's what this is doing right here, guys. Okay. All right. So what Docsback was saying is if we alter the ID, possibly we might be able to change some of how this neighborship and all this is working out. Because right now router 4 is the designated backup router for pretty much everybody. But let's do this. All right. What I want to do, let's do a ping. All right, let's ping. Actually, let's do a trace route. Let's do a trace route. Let's do a trace route to 10.0.5.2. You know what? I should have kept all that stuff up there, but I didn't. Let's do, because it's all connected so easily. Let's come down here. Let's do a trace route here. Trace route 10.0.5.2. That's via 1. Trace route 10.0.3.2. Let's do this. I'm going to shut off some of these gigabit interfaces, and then let's see what happens. All right. Interface, gigabit 0-0. 0, and let's do a shutdown command on that one. And let's come over here to R4, and let's go into the gig interface, gigabit 0-1-0. Let's do a shutdown command on that one. All right, so that's good. And let's do a shutdown on this one too. Try pinging the loopback on router 4. All right. Let me just shut down this one more interface. That way we can kind of look at how everything starts to change. Gigabit 0-0. Let's give this a shutdown. Okay. All right. Let that come up. So we should, let me see. We should still have communication throughout our networks here. All right. So let's do a trace route, actually. Trace route to 4.4.4.4. See if you can give me any information or not. Yeah. Yep. Yep. On every router. Yep. Yeah. Everything's in area. Everything's in area. In area 0 on every router. And I could take a look at that. So. So router OSPF area 0. Router OSPF area 0. Same thing. Yeah. If you configure to share the 10 network only. Not all network. Not all. No, it's so. Are you saying the wild? how I did the wildcard address? Is that what you're saying, Mad Docs? I can spell. So this wildcard address, the 255, the 0.0.255, all that's saying is that two right there is the network, and then the rest of it is host bitsies over here. This is broken. I don't know why this is doing what it's doing, but I should be able to ping 4.4.4.4. No, I guess not. Only got a neighbor C. Let me do this then. Oh, I see what you're saying. I see what you're saying. So are you saying then to do the all zeros, configure the all zeros in OSPF in area 0 then? And that's probably why I can't ping the loopback address, right? Hmm. All right. I see what you're saying. OSPF, which one? Network 0.0.0.0.0.0 area 0. Drop it out. OSPF 1. That's probably exactly why I'm having these issues. 0.0.0.0.0.0. OSPF 1. Zero, zero. All right. is oh, that didn't change anything. You should be able to get to here, there, and there, right? Creates route. Try removing the previous network command with no network. Where am I at? So, yeah, I think we just. Think we just screwed up Poochie on this one. And now we can't even make an adjacency now. Let me do a do show run. So there it is. So there's our router OSPF 1, network all zeros, area 0. So we have that now. But now yeah. It's up in the Discord for you, Mad Ducks. My boy, Ducks bad. Let's do this. Yeah. All right. Mm. Oh wait. Now if we look at let's look at our IP routes real quick. Do show routes. We're gonna see no OSPF because we just removed we just pretty much grenaded OSPF from being able to work in our network here. So the only connected routes that we have are the routes that are physically connected to us. Okay. Now, what Docsback was trying to get me to do was he was trying to get me to ping the loopback address, which we should be able to do. But I'm running into what I am running. Oh, I see what he was trying to get me to. All right, so let me exit out of here, and we'll run the clear. SPF. Process. Does that not have it? We'll run this on everything. We'll start back. We'll start back to where we started. All right. Now let's do a do show run again. And everything should be cleared out, right? All right. So OSPF is cleared out. It might have been my wildcard addressing, now that I think about it. All right, what router am I on right now? I'm on router 1. All right. Well, let's try this again. Router OSPF 1 network 10.0.0. Now just bear with me, everybody. And then network 0.0.0, and we're going to say 255. All right, cool. All right. So that might have just fixed it right there. And to prove that, let's do this. Where am I at? So let's not do that other network on this router, and then we'll see if we can ping the loopback address. So from router 2, we were just able to ping the loopback address on router 1. So let's do this. All right, I'm going to say network 10.0.0.0. 0. All right, now let's see if we can ping the loopback address of router 1. We just made it adjacency, so there we go. So now we can ping the loopback address on router 1. And we didn't add that other network in either. So I don't know what kind of begs the question of what was happening earlier. So that even begs me the question then. I shouldn't need that other default 1. Look at that, though. But look at that. I can't ping router 3's. Oh, I see it. Now let's do this then. No. Huh. You are right. You are right. You're thinking right. All right, so network 0.0.0. Huh. Yep. There we go. All right. So we got it up. Docs back. So it was a combination of the wildcard addressing that I was doing. Why was it doing that? Because that honestly don't make no sense. It does make sense. Oh, I'm an idiot. See, this is where wildcard addressing and everything else gets a little confusing. Because, so the 2 for 5, the 2 for 5 on the wildcard address is pretty much saying this, it can be anything. So the network 0.0.0.0 at the wildcard address 2 for 5, 2 for 5, 2 for 5, 2 for 5. That's where I was messing up. You're exactly right, Matt. Doc's back. That is saying from any network at all inside of this complete area 0, we can ping. Now we can ping everybody's loopback address. So let's do it. Do ping 1.1.1. We'll ping router 1's loopback address. And there we go. So, all right. There we go now. All right, let's do a do show IP route. And if I can spell. And there we go. So now we have populated everybody's loopback addresses in here. All right. Check from R1, pinging R4's interface. Which interface? The FA interface or the gigabit interface? Let me just do a do show. So the loopback. There we go. So you were right about that. I just did the wildcard addressing wrong. right here. Instead of, I put all the zeros, as you could probably, if I could scroll back up. So right here, this is where I went, this is where I went wrong right here with my wildcard address. I did it all for the all zeros wildcard, which I went back and then I figured out that's what I was doing wrong. So we changed it for the 2 for 5, 2 for 5, 2 for 5 wildcard address. And now, as you can see, now we can ping everybody successfully. Oh, don't do this again to me, Twitch. Oh, Twitch, don't break on me. All right, now let's take a look-see. All right, router ID stuff now. All right, now to kind of go back to what I wanted to try to do before was grenade. Great. You know what? I need this show. I need a. This is what I wanted real quick. Just because I need to just write these down again. So, because I keep stinking forgetting. So this is the all threes network here. All right, this one is the twos. And this one's the fives. Then this is the ones. Serial 3 is the 6. Okay. This was be the 4s then. All right. I just had to write that down again, guys, because I kept on forgetting where the networks were. All right. So where are we at? So let's from router 2 here. Let's grenade the 2's network. So interface gigabit 1-0. Do the shut on that interface. So the 2 network will be down. I also want to take down the 4 network. Interface gigabit 1-0. Shut down. All right. So that leaves that. That one's down. That one's down. Then I also would like to, let's take down, yeah, let's take down this one too. Interface, gigabit 0, 0.0. Okay. All right. Now I want to do a trace route to, let's do a trace route to the loopback on R2 now. So what route did we take? All right, that's working. So we took the 5s, we took the 5s to the 3s to the 6s. So we went here, here, and then here, obviously to get back to router 2. So everything is working that way. Then to get to, let's do a trace route on this one. All right, everything's working. We'll do a show IP routes again. All right, very good. All right, so OSPF is doing what it should be doing. And thank you very much, Maradox back. You're awesome, dude. I appreciate your knowledge and your yeah, and you're just hanging out with me, man. You're pretty awesome. All right. So we got that. Now let's take a look. Now remember on when we looked at R4, originally. It was the DVR pretty much for everything. Now let's just take a look at that. Let's take a look at that again. So show IP OSPF neighbor. And then let's do a show IP OSPF database. And let's do a I'm just looking at these show commands. All right. All right, it's not a really good one too. It's too much on that one. So let's do the neighbor detail then. And this is where it's going to show us the, just clear this. It's where it's going to show us that information again. Okay. So, all right, so we came, so neighbor 1.1.1, so neighbor, so over here, router 1, state is full, DR, so now we're the actual DR now, the designated router, and R1 has become the DVR. Same thing again. So on for router 3 over here, off of the all threes network, we became, now is that due because of the higher IP address? I'm wondering. That's the OSPF process. Router ID. I'm gonna memorize the entire OSPF process stages. Yeah. Oh boy. OSPF is something thick. Alright. I love OSPF. Again, just don't know how it really works yet. Alright, you know what we should do? We should jump over back to the book. That way we can do some reading on where I'm probably getting mixed up on. Well, at least where I'm having some gaps. There's a shortcut to memorize them. ITL? Is that ITELF? What's that acronym? ITL. ITL. Downstate. B initialized state. A two-way state. D EX start state. E exchange state. F floating state and full state. Downstate, initializing state. I suggest serial links for any other purpose too. A downstate, initializing state, two-way state, EX start state, exchange, loading state, full state. Let me see if I can get to where it is. Guess I jumped too far ahead on this one. All right. What I'm going to have to do is we're gonna have to go through this chapter by chapter, just because there are too many gaps in my OSPF knowledge here. Yeah, all right. let's let me take some more water. Let's all right. Let's pick up kind of like where we kind of left off on this. That way I can kind of fill in some of these gaps. These kind of gaps that I got already. Like I guess what I'm trying to say is I need to hit this text hard. So all right, let's just get into it. A routing protocol underlining algorithm determines how the routing protocol does its job. The term routing protocol algorithm simply refers to the logic process used by different routing protocols to solve the problem of learning all routes, choosing the best route to each subnet, converging in reactions to changes in the internetwork. Three main branches of routing protocol algorithms exist for IGP, so interior gateway protocols. All right, IGP, interior gateway protocols. So we have distance vector, something called the Belford after its creator. Advanced distant vector, sometimes called balanced hybrid, and then link state. Okay, so if I'm not mistaken, distance vector is like what RIP was working off of, and then link state is what OSPF and I believe ERGRP are working off of. So let's just read it. Historically speaking, distant vector protocols were invented first, mainly in the 1980s. Routing Information Protocol (RIP). So Routing Information Protocol (RIP) was the first to popularize used IP distance vector protocols with Cisco proprietary interior gateway routing protocols (IGRP). All right, being introduced a little later. By the 90s, distant vector protocol somewhat slow convergence and potential for routing loops drove the development for a new alternative protocol that used new algorithms, link state protocols, okay, in particular. OSPF, open shortest path first, and an integrated intermediate system to intermediate systems. ISIS solved the main issue. They also came with a price. The regular extra CPU and memory on routers with more planning required for the network engineer. All references to the OSI in the chapter refer in the OSI version 2 unless otherwise stated. All right. Around the same time as the introduction of OSPF, Cisco created a proprietary routing protocol called Enhanced Interior Gateway Protocol, EIGRP. All right, Enhanced Interior Gateway Routing Protocol, which used some features of early IGRP protocol. EIGRP solved the same problem as did link state routing protocols, but EIGRP, regardless, required less planning when implementing the network. At the same time went on, EIGRP was classified as a unique type of routing protocol. However, it used more distant routing features than link state, so it was more commonly classified as an advanced distant vector protocol. Okay. Routing protocols choose the best route to reach a subnet by choosing the route with the lowest metric. For example, RIP uses a counter of number of routers hops between the router and the destination subnet, as shown in the example. OSPF totals the cost of the associated with each interface with the end-to-end route, with the cost based off the link's bandwidth. List the most common IP protocols and some details about the metrics. All right. So his RIP, the metric is a hop count. Okay. The number of routers hops between a router and a destination. So that's how RIP was making its choices, was the number of hop counts. Here we go. OSPF, cost. The sum of the interface cost setting for all links in a route, with the cost defaulting to the base of the interface's bandwidth. So the sum of the interface cost for all links in a route, with the cost defaulting to the base interface bandwidth, okay? EIGRP, oh, don't do it, Twitch, don't break. All right, EIGRP calculation based on bandwidth and delay. Calculation based on the router's slowest link and the cumulative delay associated with the interface in the route. A brief comparison of the metric used by older RIP versus the metric by OSPF shows insight into the way OSPF and EIGRP surpasses RIP. In the figure shows an example in which router B has two possible routes to subnet 10.1.1.0 on the left side of the network, in a shorter route over a very slow serial link to at 1500 kilobytes per second on a longer route over a 2 gigabyte Ethernet WAN link. So what is it demonstrating? So RIP. Oh, I see what it's saying. I see what this is saying. So what it's showing here is so RIP. That's horrible. RIP would take the shortest vector. Okay, so since these are one hop away, RIP would just say, okay, these are one hop. I don't care about the bandwidth that I need to deal with. All right, even though it's a super slow bandwidth, it's just thinking, okay, I'm one hop away. I just need to go this way then. Where OSPF, on the other hand, all right, it's looking at what the cost of the bandwidth would be. All right, and it kind of made that smarter choice, those smarter decisions when forwarding. All right, at least when telling these routers where these routes where they should be forwarding this information. All right. On the left side of the figure shows the result of RIP in this network using hop count. Router B learns of the one hop route directly to router A through the serial 0-0-1 interface. B also learns of a two hop route through router C through router's B gigabit 0-0 interface. Router B chooses the lower hop count, which happens to go over this slow speed serial link. The right figure shows the better choices made by OSPF based on the metric to cause OSPF to make the right choice. The engineer could have used the default setting based on the correct interface bandwidth to match the actual link speed, thereby allowing OSPF to choose the faster route. The bandwidth interface subcommand does not change the actual physical speed of the interface, just tells the iOS what speed to assume the interface is using. We can actually probably take a look at that too. What do we got? So if I go back here. One. OSPF uses for reference on any links as are equal to use the fastest connections. There is the cost assigned to fast Ethernet. Reference bandwidth of 100 would be equal to 1. So from OSPF's point of view, an interface with an interface bandwidth of 100 megabytes per second has the same cost as an interface bandwidth 10 with a 1 gigabyte per second, 10 gigabytes per second. So making the best path determines the reference bandwidth must be notified to a higher level value of 100 megabits to accommodate faster links than 100 megabytes per second. All right, let me read that one more time. So from the OSPF point of view, on an interface with a bandwidth of 100 megabytes per second, has the same cost as an interface with bandwidth. So making the best path determine the reference bandwidth must be modified to a higher value than 100 megabytes to accommodate for that. Oh, okay, I get what you're saying. I get what you're saying. All right. Does that come up when we did any of the... All right. All right. Let's take a look, see what happens here. Now, did it take this route? Yeah, so it took the gigabit route instead of going the, because that would be 1, 2, 3, 1, 2. So that's 3 hops. 1, 2, 1, 2, 3. Now, if I were to let me go from here. Let's see what would happen. Trace route 2.2.2.2. All right, so that kind of proved something too right there. So again, instead of it taking the one hop approach over the serial link, OSPF actually had router 3 go through the gigabit interfaces to get to router 2 over here. So that's kind of like what I wanted to type of what I kind of wanted to see with what that just talked about. So from R3 over here, instead of it going to its shortest path here to go to router 2, what it did was it actually went through the gigabit interfaces to get to R2. All right, so it took the faster path instead of going over this serial link here. And to get what to DocsBax is saying is the cost equal to 1. Now, let's do this then. Let's do this. Let me, 0-0 shut. Let's turn this one back on. All right. So now let's do this thing. So we'll go back over here. Do a trace route to 1.1.1.1, and let's see where we went. So it took the fast Ethernet, which I guess would make sense because it would make 3 hops, so the cost probably would have been greater. Let's take a look at these costs. Where's my book? How do I take a look at these costs? Cost. It showed let me just do a show IP OSPF database maybe. Is it going to show me cost? No, it's not going to show me cost. Database summary then? No. No. Neighbor or neighbor detail. Let's go neighbor. Trying to find a show command that will show me the cost. Ah, there we go. All right. Beautiful. That's what I wanted to see. So we got a cost of 1. And that's what you was talking about. And then that can be what you're saying is So if that's a cost of 1, let's take a look at this one. Show IP OSPF interface. So the FA0. All right, so you're exactly right. So they both have a cost of 1. And that's what you were saying. So the fast Ethernet right there has a cost of 1, where again, the gigabit Ethernet has a cost of 1. All right, I'm starting to get what you're saying. All right. So can that be altered then? If we can increase or decrease the cost value, so we can manipulate cost. It's saying route. And that's not administrative. That's different than administrative distance, right? Ah, here we go. All right. This section calculates the best routes for OSPF custom to 19. The Cisco routers have 3 different ways to change the cost of OSPF directly using the interface subcommand IP OSPF cost. All right. So let's do this then. Where did I pin? All right. Oh, what's going on? How we doing, Jane Sabah? Doing good, my friend. We're having some fun with some OSPF. How far are we getting affiliated? So I got to 50. Thank you everybody. So we got to 50 followers. I just need 3. I need a consistent. I need 3 viewers. I need a 3 viewer average over my hours of streaming to get to affiliate. So I'm almost there. I'm at 1.76. It's mainly because I've been streaming, I guess, for so long with an average viewership of 1, almost 1.5. So I need to hopefully boost my viewership up so I can at least average at least 3 viewers per stream to get to affiliate. So we're almost there. And I want to thank every single one of you guys out there for helping me to get to 50 followers, because that was an amazing achievement for me so far. So I am super pumped up about that. But what we're going over today, we're going over OSPF right now, and I got a good. You can get more bots that stay in the stream to help out that average. More bots. I need more bots. No bots. Is that how? That's probably how that guy today broke Twitch today with his 2.5 million viewers watching him buy a skin off of Fortnite. Joe bought. all those I have all those bots in here, but they don't add to the Nightbot and stuff like that. They don't add. At least I don't think so. They don't add to the viewership. Because I got Nightbot in here, and I got Streamlabs bot in there. All right, let's do this though. What I want, trace route 1.1.1.1, and then I want to alter this because I want this to cost more. So we're gonna come over here. We're gonna go to our interface. I'm gonna increase the cost to the fast Ethernet. Then we'll see. So, oh, what's up? Thank you so much for that follow. You the man. Thank you so much, Jane Sabib. I appreciate that. Jane Sahab. Am I pronouncing that Jane Sahab? Is that how you pronounce that? Thank you, thank you. I appreciate that so much. You just made my day. You pumped me up. All right, so let's IP. Sahab. All right, Sahab. I just wanted to make sure I was pronouncing that right. Thank you so much for that follow. OSPF. I'm going to say cost. The cost will be 5. All right. Now, let's come over here. Let's do that. Let's run that same trace route. And look at that. All right. Maradux. So, thank you so much. So what we just did is we just increased the cost of the fast Ethernet link that we have going to R1 up here. All right. And what that did is that altered the route OSPF took. Instead of it going from R3 to R4 to R1 via the fast Ethernet, it went from R3 to R4 to R2 to R1 to get to R1. So by increasing the cost of a link, okay, because, and this is what was brought to my attention, fast Ethernet has the same cost value as the gigabit Ethernet. So I want to know though, what is the, let me do a show, I want to know the cost value OSPF interface. I want to know the cost value of the serial link because that's something I didn't actually look at. I'm going to say SC. So the cost, okay. So the cost value of that serial link is 64. All right, 64. That's why it was avoiding going over that serial link. All right, cool. So we're learning some stuff here today. All right. So the cost value of that serial link was 64. That's the reason why it was avoiding taking that route when we had it the other way around. Okay. All right. So we just covered cost, and let's do a there's a brief command too that I didn't look at. Show ISPF brief. Syscommand not in Cisco Packet Tracer? No. Nope, it is not. I always get discouraged when a command is not in Cisco Packet Tracer. Oh, okay. All right. So serial links by default, and okay, I see what you were saying. So the serial link by default is a cost of 64. An Ethernet link is a cost of 10. Fast Ethernet, gigabit Ethernet, 10 gigabit Ethernet, and 100 gigabit Ethernet all has a cost of 1. All right. For instance, an enterprise with the fastest links set all routers. Okay, so there's an auto cost reference, meaning okay. So there's an auto cost reference. Command as well. So let's we're gonna say no IP OSPF. Okay, but what we will do is this. Let's exit out of this. We'll say auto. Is that a configuration mode? What is that? That might not be. Yeah, auto cost reference may not be in Cisco Packet Tracer. All right. So we discovered some new stuff with that then. All right. And then we covered RIP and OSPF, the differences, other interior gateway comparisons. All right. So what do we got? Algorithms, Cisco proprietary, convergence. All right, so I guess let's cover this real quick. Classful sends masks and updates, supports variable length, subnet mask, and they're all covering that one. Algorithms, DR, advanced, DVR, and LS. All right, so distant vector. So distance vector, that's what DV stands for, advanced distant vector, and then link state, LS, link state. Supports manual summarization, yes. Cisco proprietary, no, yes, and no. So EIGRP is a Cisco proprietary. All right. Routing updates are sent to multicast IP addresses. They send all of their updates via multicast IP addresses, and then convergence, and then slow, fast, and fast. All right. Advanced distances. Administrative distances. So administrative distances, this is what when we were setting up, what was I setting up the other? Oh, when we were doing static routes and routing earlier, when we were setting up like floating static routes and stuff like that, we were assigning administrative distances, so the routers would send it certain ways. So remember, OSPF has I didn't want to copy that, whatever. OSPF has a administrative distance of 110, But a static route, so a route that you configure yourself, has a cost of 1. So a static route is would be a more convincing route than, say, OSPF or RIP or EIGRP. All right, but a connected route obviously has an administrative distance of 0. Okay, BGP is what gets used in like the big internet. Well, BGP is what gets used between autonomous systems. Okay, autonomous systems. So if you can look at this figure here, what we have is multiple autonomous systems with OSPF or IGRP being the routing protocol inside of the autonomous systems, but BGP is the routing protocol that is used between autonomous systems here. Okay. All right. And BGP has a administrative cost of 20. All right. IGRP, a cost of 90. EIGRP, a cost of 90. RGRP, cost of 100. OSPF, cost of 110. ISIS, cost of 115. RIP has a cost of 120. So then there's IGRP external routers, and that has a cost of 170. But you also have a BGP interior routing protocol 2, which has an administrative cost of 20. So that's, as you can tell, so exterior routes, it has a cost of 20, but interior routes, it has a cost of 200. Okay. Then we have DHCP here with default routes. Okay, that has a cost of 254. All right, 254. And then unusable, we have a cost of 255. All right. The show IP route command lists each route distance as the first of the two, and the numbers inside the brackets. The second number lists the metric. So if we to come here, do show IP route. So what we got here, all right. What do we got? So we have a administrative distance of 110, and we have the protocol being used right there. Okay, so administrative cost of 110, administrative cost of 110. Obviously, these are connected routes. Those have a cost of 0. All right, so there's that 110 cost right there on that show IP route command. All right. And then we're going to get into link state database. And this is what we were talking about with the cost and whatnot. Flooding LSAs using link state database routing protocols, applying SPF mask to find the best route. OSPF overview. Link state protocols build IP routes with a couple of major steps. First, the router together build a lot of information about the network. Routers links IP address, status information, and so on. Then the routers flood the information, so all the routers know the same information. At that point, each router can calculate routes to all subnets, but from each router's perspective. All right, so we have topology information and LSAs. Routers use link state routing protocols needed to collectively advertise practically every detail about the interior network to all the other routers. At the end of the process of flooding information to all routers, every router in the internetwork has the exact same information about the interior network. Flooding a lot of details information to every router sounds like a lot of work. In relative to distance vector routing protocol, it is. All right. Open shortest path first, OSPF, the most popular link state IP routing protocol, organizes topology information, uses using LSAs, all right, LSAs and link state databases, LSDBs, all right, LSDBs, respect the ideas. Each LSA in the data structure with some specific information about the network topology. The LSDBs is simply the collective of all LSAs known to the router. So the link state database is simply the collection of all LSAs known to the router. So the link state, I'll get you the actual terminology here. So there we go. Link state advertisements. So in OSPF, the name of the data structure that resides inside the LSDB and describes in detail the various components in a network, including routers and link subnets. Link state databases in OSPF, the data structure in the RAM of the router that holds the various LSAs with the collective LSAs respecting the entire topology of the network. Okay. Then we have link state request, an OSPF packet used to ask neighboring routers to send particular LSAs. Link state updates, an OSPF packet used to send the LSAs to a neighboring router. All right. So we have LSAs, link state advertisements. Yep. Link state advertisements, and then link state databases. Okay. All right. And here is some information. So topology requests the information about the internet, open shortest path, the most popular respective LSAs. Figure shows the general idea of flooding process with R8 creating and flooding its routers LSAs. Or routers LSAs for router 8 describe the router itself, including the existence of subnets 172.163.0.24 as seen on the right side of the figure. So it's pretty much flooding it all out. And here's that router ID. So the router ID loopback address must be 8.8.8.8. And the figure shows the rather basic flooding process with R8 sending the original LSAs for itself and the other routers flooding the LSAs by forwarding it until every router has a copy. The flooding processes cause every router to learn the contents of the LSAs while preventing the LSAs from being flooded around in a circle. Basically, before sending the LSAs to yet another router, the router communicates asking, do you already have this LSA? And then sending the LSA to the next neighbor only if the neighboring has not yet learned about the LSA. Once flooded, the routers do occasional reflood of the LSAs. Routers reflood the LSAs when some information changes. For example, when a link goes down or up, they also reflood the LSAs based on each LSA's separate aging timer. So that's what you were seeing when we were bringing all the links. When we were shutting down links and bringing up links, you were seeing those LSAs go back and forth. And yeah, I got rid of all that. All right, let's go to simulation, and let's go to edit filters real quick. I don't want to see everything, just OSPF. I'm not using version 6, so that don't matter. I wished it saved my settings on here. It never does. Wish it did. Oh, I got a question for you, Maradox. If you're still in the chat, or if anybody else is out there, was the boson, so I want to know, was the boson any good use? Was it, well, is it at least worth the money? And if anybody's in YouTube watching, was the boson um, network simulator or anything like that worth any money? Because I want to say like it has like sometimes like a step-by-step walkthrough on some of their lab topology stuff. But all right, so what we'll do is we're going to come over here to R1 interface gigabit 1-0 and oh wait, epic, not what I wanted to do. Still going to translate that, isn't it? Let's go run to the bathroom. All right, that's done doing its thing. Okay, so let's go back to simulation. Let's go back here. Interface gigabit 1-0. Now, we should, when we do this, we should see those OSPF messages go out when we bring this interface back up. We'll give it the no shut. And that's what we're seeing right here. Which router did I shut this off on? This interface then? Forgot already. Ah, there we go. That's what I wanted to see right there. So we just brought this link back up, and now we're getting we're getting those OSPF messages. Let's take a look at them. So we're sending out our OSPF hello. Destination. Oh, look at that. They're sending out a packet to every single buddy. And there's that IP address, the 224.0.0.5. There it is again, 224.0.0.5. So there's that multicast address right there. So out of every single interface, it's sending out a multicast, so it's flooding out through a multicast address to 224.0.0.5, okay? And that's what we're seeing right here, guys. I hope you guys can see that right there, okay? There's that multicast address. All right. And it's saying the OSPF. It's pretty much looking at, it's the OSPF hello message. Now let's take a next look. And boom! Look at that. I love that. That was pretty cool. Everybody was like, everybody got hit up on that one. Now let's take a look what we got here. So a link state update, okay? To obviously the source, the 10.3.2, 10.0.3.2, and that is on router 4 over here, and that is on which interface is the 3 network? I believe this is the 3 network right here. From the 224.0.0.5 destination address, okay? We got a link state update. A link state update. Same thing here. Yep. Obviously, just getting to the other interfaces. So it's just updating all the interfaces. I haven't seen anything from the. That was just the originating message. Okay. Now let's hit this again. Oh, that is so cool. And there's the acknowledgement now, okay? Because so what we had first we had the hello, so we have the OSPF hello message, okay? Then we have the link state update. Still one of the link state updates. That's the original hello. And there's the OSPF acknowledgement, okay? This is just another acknowledgement here. Yep. Again, there's another acknowledgement. And these guys are just sharing the last bit of their information to each other. So now R2 is sending out. So the process starts all over again, huh? So does this mean that, is this just R2 doing this thing, or is acknowledgements? No, every router is just doing it. All right. And then you can just see the routers going back and forth, sharing their OSPF information with themselves. But you could see when we initially, when we brought that link state back to the up, all right, OSPF did a huge flood through everybody to share that information out. That way we can everybody can get an updated so everybody can update their routing information. That was pretty neat. All right, let's reset this sim. Now, what I want to do is this. Let's go back. And we'll go into interface. 5.0. 2.0 again. We'll give it an IP OSPF cost. Again, we'll give it a cost of 10. All right. Take a look at that packet. See if there's any information we can derive from it in this packet. It's just, again, here it is. It's flooding out that same multicast address, the 224.0.0.5. All right. And it's sending it to, this one's going to router ID 4.4.4. Well, this is where it's coming from. This is the outgoing. Advertising router. Here we go. Here we go. Here's some cool stuff to look at. So inside of our actual packet, it's showing us our metric. And remember, we just changed that metric on the FA0 interface. So this is the FA0 interface. So router, OSPF router link. So on that FA0 interface, we just changed that the cost value to 10, and it's changing the metric over here to 10. And if I was to look, let's see what happens here. I want to capture a packet going over that way. Very good. So it was just advertising that metric, and that's what we were just taking a look at. Now let's restart this. Come over here. And what I wanted to do, so I just increased the cost of that. Now let's do a trace route to 1.1. Let's do this. Let's do a IP OSPF 20. Okay. Now let's do a trace route to 1.1.1. Oh, I took away those messages. That's why we're not seeing it. CMP. All right, let's just do a ping. That trace route was no good. All right, so it's ping. So we're going from R3 to R4. Again, this link's still up, but we gave it a different cost value. From R4 to R2. Because again, it's not going to go over this link right here. And then to there. All right. Just, I guess, another way so you can alter your routes on how. Oh, snap. So that was cool. So it went pew, pew, pew. And then over this, because this, on this interface. But wouldn't it have sent it that way then? Let me see how that works again. Yeah, I was going to say, okay. Because this link over here. Yeah, okay. It was weird how it sent one packet through that route right there. It's doing it again. Why is that doing that? Now that's weird. But when it sends its reply, see, look at that. That's cool. So when the request goes out, the request goes that away. But when the reply goes out, the reply, that's cool. All right, now we're into OSPF messages too. All right. So I know I kind of released my Discord a little bit earlier than I wanted to, but I'm still going to be working on it, guys. Just for the meantime, just be respectful in it. If you joined on, there'll be more. There'll be more to come. There'll be more to come on it. Oh, you're good, brother. There'll be more to come on my Discord, anyways. But yeah, so thank you everybody for joining today. I appreciate everybody who hanged out with me today and hung out. You guys are amazing and awesome people. I love every single one of you guys, so thank you. We'll be back at it again tomorrow night. We're continuing on with our OSPFing. And yeah, we'll continue on with our studies, guys. So but without, that's it for now. So let me go to my exiting type chain, my exiting thing. We'll play some music. Let me get my music up and running. guys are awesome. All right. Hang out with me for just a couple minutes, guys. Gonna go raid somebody. We're gonna raid. Hang out for 1 second. We're gonna go raid. I'm gonna go raid my boy Rad Gnarly over here. Hope I spelled his name right. I think I did. All right, everybody. Yeah, thank you again, James Sahab. I appreciate the follow today. Everybody else, you guys are awesome, amazing people. We're gonna go raid my boy Rad Gnarly. He's a cool dude. Hit him with a follow. He's awesome. He's a funny. So, again, guys, you guys have a great evening, and I'll see you guys again tomorrow. All right, everybody.
Joseph, thanks